Um, awesome. So next up, we have a speaker that I am always really excited that whenever we can talk him into coming out here and sharing his wisdom. He's been doing distributed computing before us marketing people showed up and called it cloud. And I've been called a fanboy of this particular person. And, you know, I do actually have a tattoo of his face, which it makes it hard for me to defend. But I will be exclusively revealing that tattoo on Twitter later, so you might want to check that out. And of course, I'm referring to the Vice President and CTO of Cloud Computing from Cisco, the one, the only Lew Tucker.
Welcome, everyone. It's actually such an honor to be here with the OpenStack community. And I often want to use these events as a time to sort of look where we've been and try to project where we're going to be as we go into the future. And I'm envisioning that as being this true world of multi-cloud computing. As we know, the internet continues to disrupt entire industries through these successive waves of innovation, whether it be in hospitality or in transportation, delivery of media services, and in cloud computing itself. And the impact in cloud computing has then also changed the way we think about machines. Nowadays, it's not unusual. We've seen 100,000 cores. We see warehouses filled with commodity rack-mountable servers. And this wasn't always the case. In fact, if you look back over the history of computer science, when we had vertically integrated machines going after speed, whereas what we know now is that scale trumps everything else. And in fact, these other machines now, you can see them in the Computer Museum. And there's a picture of one of them here I'd really like to call out here, a shout out to a connection machine, which I helped design, which is now going into the Museum of Modern Art in New York City next week. So cloud computing is clearly one. And almost every company now is having to adapt. 85% of the corporations are saying they are evaluating or using cloud computing. And those that are, 94% find that they're using multiple clouds. And so this means that Cisco itself has expanded our cloud portfolio as we continue to grow in the kinds of services and offers that we have for our customers, from our hybrid cloud solutions to applications that are delivered through the cloud, such as Meraki and collaboration services, towards security delivered through the cloud and making it possible for corporations to trust moving their businesses into the cloud, and as well as our traditional line of networking systems and cloud professional services. So one of the things that I think that we're realizing, though, most recently, however, is that there are still a number of challenges facing customers, particularly as they're now trying to understand how do they use their existing data center, their so-called private cloud, with a public cloud. And in fact, whereas we originally thought cloud computing was going to make everything so much easier, in fact, this is making it more complex. Because now your data might be spread over multiple systems. How do you handle authentication? How do you handle identity management? And how do you have the controls around so that you can trust that the services you're connecting to are those that you should be connecting to or your users should be connecting to? So this has been a real challenge that we see as we move into this multi-cloud world. So the customers are now asking, okay, so how do I evolve? How do I change my infrastructure to take advantage of these capabilities? How do I manage this kind of a hybrid cloud environment? And even more importantly, how do I develop new applications and services going forward? These are all the kinds of things that we at Cisco have been looking at, and we really have arrived at a kind of a strategy around multi-cloud, meaning that we expect customers to naturally use multiple clouds in addition to their own private data centers. It's not an either or, it's an and. And so what we want to be able to do is make it easier for customers to consume applications wherever they might be. So recently, we announced a partnership with Google in terms of making it possible for customers to take advantage of best of both worlds and combining the respective strengths of our two companies to make this possible. When we look at it again, what we are finding out is that customers wanted to be able to develop in the cloud or develop in their private data center and then deploy anywhere. They needed to be able to break down the barriers between private cloud and public cloud so they can access information on both sides or in any place in the world. At the same time, they still need to be able to enforce their network and security policies and be able to do that without losing a lot of the agility that they get by going to the cloud in the first place. And lastly, what you'd like to be able to do is there are so many new services around big data, artificial intelligence, machine learning that are taking place in the public cloud providers today. You'd like to be able to incorporate those into your applications. So all of these things are what Google and Cisco now are decided to work together on to bring these out in solutions. So of course, we all know there's been tremendous advantages and advances in the last several years with Kubernetes and microservices architectures. And this is largely because when we break a big monolithic app into smaller components, you can have those components developed by specialized teams. They can work independently. And each one of those services now can be designed to do something very simple and do it very well and be very and highly scalable. All of these things now allow you to then leverage a lot of the new services that we're seeing coming out in the public cloud, as I had mentioned before. However, those of you who have worked in distributed systems, such as I have for many, many years, know that they are hard, and that complexity and issues arise when you have to have multiple services working together to deliver a solution. I'm not going to go into a lecture on the CAP theorem and other things associated with that. But as you know, when you have lots of services that are dependent upon each other now, complexity increases. And this becomes even harder when applications span multiple cloud platforms. It's not just in your own data center or in your branch offices and your data center. Now you have public cloud providers and maybe multiple public cloud providers involved. This makes it much, much harder, whereas cloud computing was supposed to be very, very simple. So let's take an example of this. Here's a service that is made up of 4 services, each one specializing in a single component of this. We can use Kubernetes and pods to manage the life cycle of these components. And now what we have to do, though, is each service now has to handle communications around it. So we have to be able to do authentication. We have to be able to do traffic management. We want to be able to do load balancing across multiple pods. All of this has to be done now by each service. When you have multiple services, now you've got multiple teams who are each having to solve these problems and to try to do this in a consistent way so that they can work together. What if we change that model and we said, let's take all of those hard services around communications and put them into another service itself, AKA a service mesh. The service mesh, we offload all those hard parts of each of those components into another service, in this case called Istio, where it does traffic management, where it can do authentication, where it can do secrets exchange, where it can interface into the security systems, where you can provide metrics for what's going on, and you get a total view of the communication between these services. This is this wonderful complement to what we're doing with Kubernetes, in that we're taking the hard parts about communication and putting that into a service mesh. In fact, this is something I'm really excited about with the partnership, because Cisco is now joining in Istio another open source project around this kind of service mesh for microservices. We're joining with Google, IBM, and Lyft, and bringing this capability forward into the world, where it can do load balancing, traffic splitting, A/B deployments. You have observability. You can do health checks. And all this makes those services now much, much easier to develop. The specialized teams can worry about how do they develop that feature and have all the hard part pushed off into the service mesh. To just quickly illustrate this, I'll take an example. We've got 2 services here, Service A and Service B. So think of Service A maybe being the front end, Service B being a sort of a back-end service providing content or access to information around the users and so forth. Each service, of course, consists of multiple pods. And we all know that Kubernetes can do load balancing across those pods, and we can do independent management of the life cycle. So one of the things we want to do now is that we want to bring up a new version of that service. So we spin up a new pod containing that service. With one line change in a YAML file, we can direct Istio to shift 5% of the traffic to that new service, aka canary deployment. Istio itself will now direct 95% of the traffic to the other pods. This way, you allow the developer to test out that new service, and if there's a problem, flip that back. If it looks like it's great, shift now 100% of traffic to the new version 2 of that service going forward. And this required only a single change in policy. None of the other services associated with this had to change. So we've encapsulated and abstracted the messaging and communication required into that service mesh, and the advantage should be obvious. So in this way now, for IT organizations who are trying to look at how do they span their data center, public cloud, multiple clouds, we can provide a consistent, policy-driven environment across the clouds themselves. And in fact, when we look at it spanning multiple clouds, now you can get access to all of the services. So from an application that you develop in a public cloud, you can access on-premise data center services. From the data center itself, you can now securely access the advanced services you might have in a public cloud. So in summary, then, I think that the long-term impact of this is going to be changing the way we think about applications and services development. With Kubernetes, Istio, and OpenStack, we can easily talk about managing applications as they are spread across multiple clouds. The boundaries, in fact, between applications and services become blurred. When that happens, application development becomes much more about an assembly process of ready-made, highly scalable, highly crafted, highly intelligent services. And that will allow us to enter sort of this everything as a service, multi-cloud world. Thank you very much.